kind of say like normal here. We're going to solve them. We're going to find the solutions from 0 to 2 pi. But what does it say in the directions to use? Use identities. Okay? So we talked about lots of identities, right? Over there to your left, what, half angles, double angles, sum and difference. What are those that aren't written over there that we're supposed to, yeah, Pythagorean identities, stolen identities, no. Reciprocal identities, okay, all that kind of stuff. Now, let's look at this. Now, if we try to do this one like we did last night's homework, we're going to run into a problem. What's the problem that you see? Yeah, one's cosine and one's sine. It's like crap. You know, if this was cosine right there, we're good. Right, but it's not. And so what I'm going to see if you can think about here is what's some identity that I can use to possibly figure out, you know, how could I make them either both sine or both cosine? No. Right. Right. In the first Pythagorean identity, right? Which is, right, what, sine squared theta plus cosine squared theta equals 1. Now, how are we going to use that? All right. Well, let's look. Well, not the 1, but what I do here, see, I've got a cosine squared, right? How can I get cosine squared in my Pythagorean identity? It would be what? 1 minus sine squared theta. Right? Cosine squared is equal to 1 minus sine squared. Now, I want to take 1 minus sine squared and put it in for cosine squared. Now, why would I want to do that? Because they both have a sine, won't they? One of them would be sine squared and the other one would be sine, wouldn't it? Does that make sense? Well, watch. So for cosine squared, I'm going to substitute 1 minus sine squared. Now, why do I want to do that? So it can go with the other sign that's in the problem, right? Right? So we'll say minus sine x minus 1 equals 0. Okay, now, what do you think I'm going to do with that? That's really basically it. I think the rest of you'll be able to figure it out. Okay. All right, yeah, distribute the 2. Okay, so that'll give me 2 minus 2 sine squared x. Okay, and I got minus sine x minus 1 equals 0. All right, let's clean it up now. Okay, y'all see some like terms there. 2 minus 1 would just be 1. So we got negative 2 sine squared x minus sine x. It would be plus 1, wouldn't it? Okay, plus 1 equals 0. Now, since those are nice and the same, we can use our quadratic form, right? Talking about right there. 2 minus 1 is 1. Okay? Now, I like that negative about the same way I like when my underwear gets stuck up my butt. I don't like it. Okay? So I'm going to get rid of it. Okay? Well, that's what I call negatives in front.
Excuse me, Mr. Tatum. At the end of class, I need to see Jake Blake in the guy's office, please.
Okay.
Thank you.
So, you know, when your underwear gets stuck up your butt, what do? You pull them out. So what am I going to do with the negative? I'm going to pull it out. I'll get rid of it. Okay, so how can I do that? Yeah, just distribute a negative. So this is going to make it say 2 sine squared x, but then what? Plus, all right, sine x minus 1. Okay, and now it's like that nice quadratic form, isn't it? So we can do our substitution stuff and truck on, can't we? All right. But the challenging part of that about the problem is not the rest of it, but it was the very first step, wasn't it? is figuring out what kind of identity substitution can I make so I can solve the problem. And so the key was to make this into something with sine squared instead of cosine squared. So you're using a Pythagorean identity to make that work. Okay? Now, let's continue solving. Now, I'm going to go pretty fast on the rest of it. Do y'all want me to actually go through and solve the rest of it, or? Yeah? Okay, let's look. So I'm going to substitute the A. All right, now, what factors of 2 that subtract B 1 would be 2 and 1. They're going to be different. It'll be plus 2 minus 1. And I did have to split that, didn't I? Okay, so now I'm going to group them. All right, so we get 2A times A plus 1. If I try to negative 1, that'll leave me with A plus 1. Yeah, A plus 1 times 2A minus 1. So A would be equal to negative 1 and 1/2. Okay, now what's A? Sine x. Okay, so sine x equals negative 1 and sine x equals 1/2. So where's sine negative 1 at? 3 pi over 2. And where is sine 1/2 at? Pi over 6. Y'all check me on the second one. 5 pi over 6, is that right? Pi over 6 I know is right. And 5 pi over 6 is right? Okay. All right. Now, but the key was that first step, wasn't it? Once you figure out what identity to use and how to use it, then it's just the same old stuff. Now, let's look at this one. Let's see if you guys can figure out what identity to use on this one. This one's a pretty challenging problem. No. So you got to. Now, the only one you're going to have to know is the first one. Okay. All right. What's the first one? Tell Hunter what. Sine squared plus cosine squared is 1. Okay. All right. Now, there's no squares here. So now they're both sines, but what's the issue? That's the argument is 2, and then this one is just x. And so that's a big problem. Now, y'all think about your identities. What identities here we talked about had 2 in front of the angle? Double angle. Very good. Nobody in second period figured that out. Double angle, right? Okay. So we can use our double angle identity. Now, y'all see what we're talking about? Let me write it over here since some people are going to be watching this on YouTube. All right. Now, you can use these too. All right. So I'm going to use this one. Sine of 2A is equal to 2 sine A cosine A. And you remember what I said about you like your double angle identities? I told you. I didn't make you memorize them, did I? But I told you needed to be familiar with them, so if you saw one, you could think about it. Okay? So, now what I'm going to do for sine 2x there is substitute this in for it. Now, I can't obviously put a's. I'll have to put x's. So, for sine 2x, I can do 2 sine x cosine x. Now, we still have an issue here, and this one's a pretty difficult one to figure out, okay? I'll give you that. You still have sine and cosine in the problem, don't you? But you do have these that are alike, okay? Now, I'm going to do this next step, and this, it's just kind of hard to describe why I'm doing what I'm going to do here, but I'm going to set it equal to 0. Now, let's see if you guys can figure out why I would want to do that. What can I do with that like term of sine x? You can't really combine it because this one's got the cosine x. That's it. You could factor it out. Okay? Yes. right here, because I had to recognize that, hey, it's a 2x thing. I need to use a double angle. Yeah. Okay. Now, so I'm going to factor out a sine x. And so that'll leave me with, what? 2 cosine x. Right. Now that it's in a factored form, we can use that a times b rule. If a times b equals 0, then a could be 0 or b could be 0. So we get sine x could be 0 or 2 cosine x minus 1 could be equal to 0. Okay? It's just like, look at it this way. Isn't that what we do when we factor? Is we see what makes both factors equal 0. All right. So now, we can pretty much go ahead and solve this one. Where is sine 0? At 0 and pi. Okay. I need to solve this one. So I get rid of the 1s. We get 2 cosine x equal 1. And then get rid of the 2. What would it give me there? A half, right? Okay. So you get cosine x equals a half. All right. So where is cosine 1/2? Pi over 3 and somewhere else. Yeah, 5 pi over 3. Okay. And I'll give it to you, that's a very complicated problem. And it's going to be hard to really remember here. Not necessarily to use the double angle. I don't really think that's the hard part. The hard part is going to be, remember, once you use the double angle, what do you do? And so you gotta bring it over, you gotta set it equal to 0 and factor. Okay. Okay. I mean, you're gonna have to realize to do that. All right. Now, and it'll be sort of easy on the homework, because probably the homework one is like 71 or 69, the odd one above it or in front of it, probably number 69, and you can look at it and figure out the homework. Right here. Right. The idea right here, let me try to explain it again, okay? You got 2 sine x's, don't you? The key is to put those on the same side with each other. And the reason I want to put them on the same side with each other is so I can factor it out. Okay? If I get 2 like terms here, where really these 2 terms are not alike, are they? But this part is, isn't it? So if I can get those together on the same side, I can factor it out and solve it by factoring. Okay? Now, I think the next one, I think you're going to do better on this one. Okay? Now, what identity on this one do you think of here? Another double angle. Okay? Now, this is a different double angle. Okay? Now, you remember cosine, the double angle for cosine, there's 3 formulas, right? So we're going to see, out of those 3 formulas, which one is sort of better suited to plug into the problem and do. So let me write out right here the 3 formulas. Cosine 2a is equal to cosine squared a minus sine squared a. All right, what's another one? 2a equals what? 2 cosine squared a minus 1. And then the other one is 1 minus 2 sine squared. Is that right? Okay, because I wasn't looking. All right. Now, which one is going to be better suited right here to put in right there? And consider what we got. The third one. Why do we want the third one? Right. If we have sine over here, if we can get a sine squared over here, then we can use our quadratic form, can't we? Okay. So I'm going to substitute this one. Yeah, it would, but it would be a lot more complicated. Okay. I'm going to use that third one because it's got a sine squared and my problem had a sine in it. Okay. Now, let's make that substitution. So what are we actually going to write right here for 1? Right. 2, crap, I can't say it. 1 minus 2 sine squared, not a, but x. Okay. Now, it's not that big of a deal. Okay, now, it's a quadratic form, and it's one we would do by factoring, wouldn't it? Okay. Now, I'm going to do this. Since that's negative, y'all want to just move everything over to the right side when we set it equal to 0? Okay, so we would get 0 equals 2 sine squared x plus sine x minus 1. Okay, now we could use our substitution and do this one by factoring. Okay, now I'm going to work it out, but I'm going to go kind of fast now, all right? So here we go. We get 0 equals 2a squared plus a minus 1. And you probably start figuring out, you get the same old quadratics over and over, don't you? Okay, so factors of 2 that subtract to be 1 would be 2 and 1. Signs are different. Be plus 2 minus 1. All right, take out a 2a out of the first group. 2a times a plus 1. Then factor out a negative 1. That'll give you a plus 1. So we get a plus 1 times 2a minus 1. So a is negative 1 and 1/2. Okay, so what's a? Sine x, okay? Sine x equals negative 1. Sine x equals 1/2, which I think was exactly what we got on the other one. Okay, where's sine negative 1 at 3 pi over 2? 3 pi over 2? Is that where sine is negative 1? Yeah, that's right. And where's sine 1/2 at pi over 6 and 5 pi over 6? Okay. Now, again, I think once you realize what double angle formula to go with, you know, once you get here on this one, off to the races. Okay. But it's that initial thought, what do I need, what kind of identity do I need to use? It's kind of the tough part there. All right, now, this next one, it's like really hard to tell on this one what to use. Now, I had like tried several different things on this problem to try to solve it when I first got it in dual enrollment. I mean, I'd like square both sides and try to use Pythagorean identities, and I kept like running in a circle. And so after about an hour of 2 hours of you know, trying to do it and a few daddy words in there somewhere, I finally looked at the example and gave in. Okay.
Hey, no, I'm so sorry, but I need the following students at the end of class. And that's Jay Blake, Autumn Gardner, Emma Rogers, Kayla Stanley, and Taiwan Thomas at the end of class, please.
Okay, Taiwan is not here today. Just let you know.
Thank you.
All right. Now, so I finally looked at the example. It's kind of like, you know, when you like get something and you have to put it together and you try to do it without the instructions. Yeah, that's kind of what happened on that. Okay, I tried to do it without the instructions and it didn't turn out too well. Now, so I'm not going to expect you to know what exactly to do. I'm going to tell you what to do here. Okay, you have to use a double angle. Now, let me show you the double angle that you're going to use. You're going to use sine 2a. Now, sine 2a is 2 sine a cosine a. Now, if you look at that, you say, well, there's no 2x's there, is it? All right. What you need to look at is this side of the double angle. Now, what do you have there that's really close? You have sine x, cosine x there. But what's missing? The 2. Okay? So, how can I make a 2 just appear right there? Can I just multiply it by 2? I can do that as long as I do what? Both sides. So I'm going to multiply both sides by 2. And that way, I can get it to say that, can't I? All right. So we'll multiply both sides by 2. All right. So now we can get the double angle. So it'll be 2 sine x cosine x. Now when I multiply the other side by 2, we can say what? 2 goes into 4 2 times, and it gives us that nice familiar value, square root of 3 over 2, doesn't it? Okay. Now we can use that double angle formula. So instead of writing there 2 sine x cosine x, what can I put in place of that? Sine 2x. Now, I don't really like that, even though I've got the problem pretty much solved. What's wrong with that? That looks fairly simple from here now. It's hard at first, but remember, we don't like coefficients. Remember what we have to do with coefficient problems? We got to find the general form and plug in n equals 0, n equal 1, and all that stuff. Okay. Yes. Because it has, why do I have to do that? Because it has a coefficient. Okay. If I have a coefficient on the argument, I got to go through all that. Okay. And which is kind of bad news, but all right. We got to do it. Now, so we're going to do the A thing. We're going to let A equal 2x. Yeah, y'all would do that. All right. So sine A equals square root of 3 over 2. So where is sine square root of 3 over 2 at? Pi over 3 and 2 pi over 3. Is that right? All right. Now, I have to do this, don't I? Even though it doesn't say find all the solutions, I have to say plus 2 pi n. Right. Why do I have to do this? Yeah, but what's going to tell me I have to do this thing? I got to remember the coefficient. Okay, and that's really tough to remember. Now, what's A? 2x. Okay, so we get 2x equals pi over 3 plus 2 pi n. Okay, so we would need to divide by 2. So we get x equals, this will give me pi over 6.
Mr. Titus?
Yes, sir.
I need to see Tamara Rogers.
Okay. All right, plus pi n. Now, let's do the other one. Okay, again, A is 2x. All right, divide by 2. So you get 2 pi over 6, which is pi over 3, plus pi n. All right. So somebody called 0. Kayla, what's the answers to that one? You called it. You got to give it to him. Pi over 6. All right. And pi over 3. Okay. So now I have to do n equals 1. Now I think that's all you're going to have to do, because when n is going to get to 2, it's going to be too big. So n equals 1. So I'm going to think of it this way. All right, pi over 6 plus pi. Now I can write pi as 6 pi over 6. Or punch in my calculator 1/6 plus 1. Okay, so this is going to give me 7 pi over 6. Okay, over here, all right, we got pi over 3 plus pi. Now I'm just going to call that, instead of pi, we'll call it 3 pi over 3. And so we'll get 4 pi over 3. Okay, and like we said earlier, when n equals 2, it's going to get bigger than 2 pi. Okay, now, so that's the thing about sometimes when you use, that's the thing about using the double angle. And we kind of used it a little backwards. When you use it kind of backwards, you end up with all nasty coefficients. Okay. Right, you had 4 answers that time. All because of that coefficient. Okay, now let's look at some here. And what we'll do, we don't really have time to like work another one out, but